Okay, now moving on to linear search, guys, the first algorithm that we wanted to look at. Let me introduce the algorithm. Linear search means that if you have a list of, let's say, 10 elements, you check one by one to see if you have found the element you are looking for. And that's pretty much it. You iterate over all the elements in that set or list, whichever data structure you are using to store these elements. You go one by one and you check each element. That is linear search, which is the simplest form of search, right? You just go one by one and you see if you have found the element. There's something called time complexity that we'll discuss when we go over these algorithms. Time complexity basically means how the time the program takes grows with the size of the input. For example, if I double the input size, will the time taken by the program be doubled? Will it remain mostly the same? Will it grow by 4 times? What is it? Is it proportional to n? Is it proportional to n squared? What is the time taken really proportional to? In this case, if you have 10 elements to compare, maybe it will take X amount of time. If you have 20 elements and you have to compare all of them, then it might take 2x time. So it's proportional to the length of the list. And this is called order of n, which means that the time will grow proportional to n, where n is the size of the input, the number of elements you have to search through in the worst case. So that's pretty much it. Linear search is probably the best thing you can do if you don't know anything about the elements, the way they are stored, or any other intrinsic information. If you don't have any of that, then this is probably the best thing you will be able to do.